In this section, we will discuss how to find probabilities, percents, or proportion using normal CDF without standardizing. Okay, so let's look at steps above. Step number 1, it hasn't changed. We've done it many times in class. You always will start the problem by drawing a normal curve and shade the desired area. Step 2. So step 2 is what we are eliminating, right? When we are saying using normal CDF without standardizing. Okay, so we will be jumping right into step 3. You will use the normal CDF function on your calculator to find area, probability, and percentage. Okay, and then step 4, sometimes it's optional. You just write a complete sentence interpreting value found in step 3. So let's continue with our examples. Example 1, we were told that IQ scores can be modeled by a normal distribution with mean equals 100 and standard deviation 15. So then we were asked, what is the probability that a randomly selected individual has an IQ between 80 and 125? Okay, so first we will draw our normal distribution, right? Step 1. Remember, it's bell shaped and it's symmetric about your mu. In this case, mu is 100, so it's right in the center. Then you have to label your IQ scores, right, that are given. So you have 80, that's going to be somewhere to the left of 100, right? And then 125, somewhere to the right of 100. Okay, so you're trying to find a probability that the randomly selected individual has an IQ between 80 and 125. So we would shade the area between 80 and 125. Okay, let's write out what we are trying to find. So probability between 80 and 125. Okay. Remember, probability means you are finding the area of this shaded region, and for that we use a function on our calculator called normal CDF. I'm gonna carry it here. So normal CDF, and it takes 3 inputs, right? Sorry, 4 inputs. So the first input is our lower bound. Lower bound is 80. Upper bound, it would be your second input, which is 125. So 80, comma, 125, comma, and then you input your mean, which is given, again, it's 800. And standard deviation goes last. Standard deviation is 15. Again, it is given in the problem statement. All right. Let's see how I would input it into our calculator. Again, you turn it on first. Let's see. Okay, and then you go second. Okay, so my calculator is not working. Okay, so you input normal CDF 80, 125, 115, right? So to get to normal CDF, remember you first click second and then distributions. Okay, it gives you a list of distributions. You go down. Number 2 is normal CDF. Click on that. Okay, and then again, lower number is 80, upper 125. Okay. Mu, in this case, mu is 100. Put that. And finally, standard deviation is 15. 1, 5. Select paste, and press enter. Okay, and then press enter again. Okay, so the answer I got is 0.8610. Let's round to 4 decimal places. So if we were to interpret our answer at the end, we can say the probability that a randomly selected individual has an IQ between 80 and 125 is approximately 86.10%, right? Remember, we can always convert our decimals into percentage. So 86.10%. Okay. Next part of the problem is asking us to find the percentile, right? Find the percentile ranking of an individual whose IQ is 136. Okay, remember from our previous classes, percentile represents the area to the left of your value. So I'm going to write it here, area to the left. Okay, and the value we are working with in this case is 136. So we would have to look for the area to the left of 132. Okay, did I say 136? Should be 132. Okay, let's sketch our curve. Okay, again, it is normal distribution, symmetric about our mu. Mu hasn't changed, right? Still 100. Okay, but now we are working with 132, so it's somewhere here and to the right of 100. Okay, and again, we are looking at the area to the left of the score. Okay, so we are trying to calculate probability of x less than 132. X is your random variable, right? Again, how do you calculate area? Just like we did before, normal CDF. So normal CDF, okay. Lower bound, in this case, it goes all the way to negative infinity, right? Never stops. So it's going to be negative infinity. Remember, on our calculator, we enter it as negative E99, comma, upper bound, 132 in this case, right? This is our stopping point, comma, mean, which is 100, and standard deviation of 15. Okay, so let's calculate that. Again, I'm going to press second, distributions, select normal CDF, enter. Now we have to enter the negative infinity, so negative button, right here, negative, second, double E right here, and then 9. Upper, in this case, the upper limit is 132. Mu and sigma haven't changed. So select paste, enter, and enter one more time. So you got a value of 0.9836 if you round it to 4 decimal places. Okay, so let's again interpret our answer. What does it mean? It means that 132 is the 98th percentile. Remember, we always round to a whole number when we are dealing with percentiles. Okay, this next problem, please try on your own. I will be posting the answers on Pearson. Okay, moving to our next objective. Our next objective is to find the value of a normal random variable using inf_norm. Okay, so in this section, we are kind of going backwards. You will be given area under the curve, and you would have to find either the z-score or your x, right? Random variable x. Okay, let's look at the steps again. Step 1, Draw a standard normal curve and shade the area corresponding to the proportion, probability, or percentile. Again, visuals are super helpful, so please do step 1. Step 2, use the InvNorm calculator function to find the z-score that corresponds to the shaded area. Okay, and I will show you how to do that when we do examples. And finally, you can obtain the normal value from the formula, right? If needed. Again, our calculators are very powerful, right? We're using TI-83 and TI-84s. So many, if we will, for this section, we wouldn't have to do this step, basically. Okay, so example 3, find the following z-score given the following areas. Again, show what you input into your calculator. Okay, so first part, find the z-score such that the area under the standard normal curve to the left is 0.2. Okay, so let's start by sketching our normal distribution. All right, so let's read the problem again. Find the z-score such that the area under the standard normal curve. Remember in class, standard normal curve, it's our special case. Standard normal curve has mu of 0 and sigma of 1. Okay, so it's symmetric to about 0. And in this problem, you are given area. Area to the left is 0.2. Okay, so this area is 0.2. What are we trying to find? We are trying to find the z-score. Okay, and for that, okay, we use InvNorm function on our calculator. Okay, and the 3 inputs that it takes. It takes the area to the left, so pay attention to that. Area to the left, it takes mean and then standard deviation. Okay, so area to the left of our z-score is, again, it's given 0.2, so that will be my first input, comma. Then you input your mean. Okay, mean, since we are dealing with standard normal curve, it's 0. And finally, standard deviation of 1. Okay, so let's look how we would do this on our calculator. Okay, so same path. So you click second distributions. Okay, and you have to scroll a little bit further. So it's number 3, InvNorm. Again, your calculator will prompt you. So it's asking for the area. Remember, again and again, area to the left specifically. So we have 0.2. And mu is 0 because we are again dealing with standard normal curve. Sigma is 1. Okay, select paste and enter. And then enter again. All right, so we got a z-score of negative 0.8416. Okay, part B, find the z-score such that the area under the standard normal curve to the right is 0.35. Okay, let me highlight that. Okay, we start again by sketching our normal distribution. And again, it is standard normal, so symmetric to about 0. Okay, so now we are given area to the right. That is 0.35. Okay, and again, we are asked, what is the z-score right here? We will use inverse norm. Okay. So remember, it takes area to the left as the first input. Okay, since I know area to the right, area to the left would be the complement of that, right? So it would be 1 minus 0.35, which is 0.65. Okay, so area to the left is 0.65, comma, mean 0, and standard deviation of 1. Okay, let's go back to our calculators. Press second, distributions. Scroll down to number 3 for inv norm. Highlight it and press enter. Okay, enter our area to the left, which is 0.65. Mu is 0, standard deviation is 1. Select, paste, and enter. Okay, enter one more time. So this is the number that we are getting. Let's round it to 2 decimal places this time. 0.39 is your answer. So again, the z-score is 0.39. Next part C, find the z-scores that separate the middle 70% of the area under the standard normal curve from the area in the tail. Okay, let's sketch our normal distribution again. Okay, so in this case you are given middle 70%, so approximately this much, right? 0.70, somewhere in the middle. And then in this case you would have to find 2 z-scores, right? So let's say z sub 1 is unknown and z sub 2 is unknown, right? So let's figure out what are these little areas right here. Okay, one of the ways to figure it out is to take 1, right, total area under the curve, subtract the middle part that is given, 0.70, and then divide by 2, since you have the 2 identical tails, right? So that gives you 0.15. That means each tail is 0.15, right? Area of each tail is 0.15. Okay, now we have all of this information. Let's find z sub 1. Again, we are looking for z-score, so we use inv norm. Area to the left. So area to the left of z sub 1 would be what? Okay, this little shaded part, which is 0.15. So 0.15. Okay. Next, we input our mu, which is again 0. And standard deviation of 1. Okay, let's calculate that. Second distribution, number 3. Okay, 0.15 for our area. Mu is 0, standard deviation of 1. I don't have to change anything. Select, paste, and enter. Enter one more time. Okay, so we approximately got negative 1.04. Okay, so remember, this is our first z-score. So z sub 1 equals negative 1.04. Makes sense, it's a negative number, right? It's to the left of our 0. Okay, let's figure out z sub 2 now. Z sub 2 equals inv norm. Okay, so I'm gonna say mu is 0, standard deviation is 1, right? Still have to figure out what's the area to the left of that. Okay, area to the left of z sub 2 would be 0.70 plus 0.15, which gives me 0.85. Right, one more time, it's 0.15 plus 0.70, because we are calculating the total area to the left of z sub 2. Okay, enter that onto your calculators. So again, second, vars or distributions, number 3, area to the left now is 0.85. Mu and sigma hasn't changed. Select paste and click enter. Enter one more time. Okay, so we got 1.04, positive 1.04 approximately, and that's our z sub 2. Okay, and the answers make sense, right? Since the curve is symmetric, right? One value is negative, and then you have identical positive value to the right. Okay, moving to our next objective, objective number 3, you need to find the value of a normal random variable using inv_nor without standardizing. Okay, basically, again, the z-score will not be given. You will be given the x value. X is your random variable. Okay, and again, you wouldn't have to worry about it because we will be using calculators, so we wouldn't have to calculate the z value, right? You just enter your x value into calculator and the answer will be given. Okay, let's look at example 4. A statistics instructor obtains height of her students. Luckily, the heights are normally distributed with mean of 64 inches and standard deviation of 4.6 inches. I'm going to write the given information actually. So mean is 64. Standard deviation, remember we use sigma for that, is 4.6. Find the height for one of her students at the 75th percentile. That is, find the height that separates the bottom 75% and top 25%. Okay, let's again start by drawing our normal distribution. Okay, in this case, notice it will be symmetric about 64, right? About your mu. It's not 0 anymore because we are not dealing with standard normal curve. Next, so what else we have? So we need to find the height that separates the bottom 75% and top 25. Okay, so bottom 75 and top 25%. And what is this value? Again, we will use inv_norm. Input area to the left of our x. Okay, area to the left is 0.75, comma. Our mean, okay, again, our mean is now 64. It's given in the problem statement. And then our sigma, which is 4.6. Okay, let's enter that. Second, distribution, number 3, 0.75, mean is 64. And then sigma is 4.6. Okay, select paste and enter. Enter again. Right. Let's round our answer to 1 decimal place this time. So we have 67.1 inches. Okay, so the height for one of her students at the 75th percentile is 67.1. Example 5. It is known that the length of a certain steel rod is normally distributed with a mean of 100. Or again, I'm going to write down the information. So mean is 100 and standard deviation, so sigma, of 0.45 centimeters. Suppose the manufacturer wants to accept 90% of all rods manufactured. Determine the length of rods that make up the middle 90% of all steel rods manufactured. Again, we are working with middle 90%. Okay. Sketch our normal curve, normal distribution. Okay, it will be symmetric about 100 this time, right? About our mean, which is 100. Middle 90%, so this middle area is 0.90. Okay, so quite a lot. Okay, so let's again figure out the areas of these little tails right here. Similarly, we will use this formula: area equals total area, which is 1, minus the middle part, which is 0.9, divided by 2. Okay, so that gives me 0.05. That means each tail is 0.05. Okay, so once again, since we are given the middle, we will be looking for x sub 1 and x sub 2, right? We have to get two answers. So x sub 1, again, inv norm, area to the left, 0.05, comma, your mean, in this case, mean is 100, and then standard deviation, 0.45. Okay, calculate that on your calculator and compare with the answer I got. Okay, I got 99.26. Okay, again, that's my x sub 1. So x sub 1 equals 99.26. I still have to find x sub 2. Similarly, x sub 2 equals inv norm, area to the left. So area to the left of x sub 2, right? X sub 2 is right here. Area to the left would be 0.90 plus 0.05, right? Everything to the left of x sub 2. So 0.90 plus 0.05 gives me 0.95 as my area to the left. The mean is 100. Okay, and the standard deviation is still 0.45. Again, do the calculations and compare with my answer. Okay, I got 100.74. Okay, so x sub 2 in this case, 100.74. And we have one more example that we will work on. The scores earned on the mathematics portion of the SAT are approximately normally distributed with mean of 516. Okay, so the mean of 516 is given, and standard deviation of 116. What score should a student obtain in order to be in the top 3%? Okay, so you can imagine you have to score very high to be in top 3%. So again, let's get our visual. Normal distribution that is symmetric about our mu, 516. Okay, top 3%, right? So it would be tiny areas to the right of 516, so right here. Okay, so you're trying to figure out what would be the score that I need to get to be in the top 3%. Okay, so x sub 1, again, inf norm, area to the left. In this case, we are giving area to the right of our random variable x. Okay, so to calculate area to the left of it, it would be again the complement. 1 minus 0.03, which is 0.97. Okay, so area to the left is 0.97. Enter it, comma, your mean is 516 in this case, and then third input is your sigma, which is 116. Okay, let's do it one more time in our calculators. Since I'm using an application, it's a little bit laggy. Okay, so again, calculate it on your own and compare with my answer. I got 734. Okay, so you have to get at least 734 on your score to be in the top 2%.